This is the Amp Hour Podcast, recorded April 20th, 2016. Episode 295. An interview with Omer Kilic. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Omer Kilic from Den Automation.
Welcome. And this is, we're actually in the Den Automation office.
Welcome to Brick Lane.
Yeah, so we're in London. Oh, yeah. I was like, oh, yeah, we were here last night, right? We were hanging out here last night, but where are we in London in relative terms?
So you're in the world-famous Brick Lane, where we have a lot of curry houses and a lot of hip bars.
And the bagel shop.
Oh, the bagel shops are the greatest.
Right. So last night we were at a meetup. There's like 25 people there or so.
Yeah, good turnout.
A couple beers, another place, couple more beers, and then the bagel shop was the place we had to hit. And I will say that was the right place to go. So
well, we're glad you liked it.
Yeah, right.
We need to take care of you. I mean, you're a guest, right?
Oh, yeah, so. Right. So that's good. So you are. How long has Den Automation been here?
So we moved in around October time. This was an empty room. Okay. I mean, of course, this is a podcast and not many people are seeing it, but there's things everywhere now, and we kind of need to find a bigger office.
Yeah, it looks like maybe, well, I don't know how many people are here every day, but you have a little lab space, you have desks, stuff like that. So.
But it's been fun. I mean, in traditional startup style, we built everything from scratch. Like, went to IKEA, loaded up like a small truck load of things. And now we're kind of developing some cool stuff here.
And we will get to that in a second. Before that, let's get some of your background. So you've done other startups, you've done electronics. Obviously, we followed each other on Twitter a long time.
Yeah, we're Twitter buddies.
Yeah, Twitter buddies.
So I started at uni doing computer systems engineering, which is kind of it overlaps the software engineering and electronics engineering practices. And I kind of focused on more of the digital microelectronics, FPGAs, microcontrollers, and PCB design, that kind of stuff. And then I liked academia so much, naive of me, that I stayed on to do a PhD. And the topics I looked at, I started with were partial dynamic reconfiguration on FPGAs.
Oh, so like the thing where you load a bit file, and then part of that bit file acts as a bootloader for the next bit file if you want to redo it. Yeah, you can
basically reconfigure parts of your system while the other parts are still running.
It's the dream of an FPGA, which actually isn't used that often, right?
No, I mean, the beauty of it is that it's really interesting. And there have been very many different ways of doing it. Even so, things that were not officially supported by Xilinx, but people kind of abusing the standard configuration facilities to do like a hacky kind of hack together reconfiguration.
Right, it's not like they're like encouraging you to do it because people think that's the right idea, but usually it's not.
Yeah, true. And Xilinx added support for this in I can't remember the ISE version. But
wait, was it the one with tons and tons and tons of disks and gigabytes of
the full
files?
Installation was something like 12, 13 gigabytes.
Yeah, that's...
I mean, ask Sar about this. He loves this stuff.
Yeah, right. Who we were hanging out with last night as well.
Yeah. So that was fun, but then I kind of realized, and the particular application area I was looking at was image processing, stereo vision. Image processing in FPGAs is fun, right?
It's great. It's a great application for it.
But then I realized I kind of had I was more interested in system level problems. So the tools and methodologies I was developing for the reconfiguration of FPGAs, I started applying them to a wider embedded systems kind of system approach.
Cool. So like loading firmware remote type stuff?
Remotely, kind of like a distribute. The thesis title ended up being something along the lines of a dynamically reconfigurable framework for distributed embedded systems. So
perfect. Yeah. Which is practical, actually. Like that's the kind of stuff that my old company used to do all the time, where you get to push updates to the field, and it's a huge. I'm sure Alicia and Chris, if they're listening, would be like, yes!
So what inspired me was like looking at all my lab buddies struggling with all these sorts of different types of systems they were inheriting from other students, and spending a lot of their time on the configuration, management, distribution, communication side of things. Right. And I try to kind of apply certain principles that I learned along the way, talking to my buddies in CS doing concurrency, parallelism, and other group of friends doing distributed computing and stuff, and applying it to an embedded kind of domain. It was fun. Submitted, defended. I still need to submit corrections. It's not done yet, but hopefully it will be out of the way after that. Okay. Towards the tail end of that, I kind of wanted to explore a bit more of the software engineering side of things, the internet, the cloud, these distributed services and so on. So I joined a company to do distributed Erlang. Erlang is
that sounds familiar. It's a programming language.
It's a programming language that was originally designed for embedded systems at Ericsson years and years ago.
Okay.
It ran, and I think
Ericsson. Whatever happened to those guys? They used to make phones, right?
They did, yes. Funny enough, we were talking about with our industrial designer in the office a couple of days ago about how awesome some of the old Ericsson designs were. Particularly like the T28, the GSM ones. I don't know if you got them in the US.
Yeah, I never really paid attention to the GSM stuff because I was always at Verizon.
The T28 had this asymmetric antenna on it that was so cool. I always wanted one, but it was terrible now that we have these amazingly beautiful smartphones and stuff. But
at the time, actually, I was just on your recommendation and a bunch of other people's recommendation, I was at the London Science Museum today.
It's so good.
It was amazing, and but they had a whole section on communication stuff, and then you get to the end and it's like, oh, this is like a wall of cell phones, and so I saw a bunch of designs as well. It was interesting. I also saw the the big brick phones and stuff.
Beautiful stuff.
Oh, I loved it. Actually, they were doing a little. Sorry, don't mean to step on your toes here.
No, that's right.
They were doing a little demo, you could they actually had phones and stuff out, and I walked up to them like, how many kids know what these things are? He's like, do you know what these are? I'm like, yes, I know what they are. I used to have a rotary phone. Come on, man, everybody. But it's
well, they don't make them like they used to.
Thank God for that.
Yeah, well, arguably yes. Actually, yes. What am I talking about? So I kind of looked at how we can play with Erlang in embedded systems because so Erlang employs this model of concurrency called actor model, where things are abstracted into their own individual units. Think of it as processes, but without the horrible kind of how do I get things communicating approach. Because actors have mailboxes, they can send messages to each other.
Oh, so kind of like when you're doing what's that called? Mailboxes are like for RTOSes, right?
You can think about it the same way. At the moment, I mean, the lineage of Erlang is again telephone switches, data exchanges, that kind of deal. Okay. But now it powers a lot of messaging systems. You must have heard of WhatsApp, the messaging app. That's powered by Erlang and stuff. So
I thought that was J2ME.
Well, I think one of their clients is J2ME. I'm talking about the back-end side of things.
Oh, okay.
But I kind of took a different approach and said, can we actually run this on the device? And we actually put out a framework for Raspberry Pi where you could abstract all the hardware concepts into, or map them into actors and have messages passed, amongst themselves and so on. So we had like concurrent blinking lights and all that stuff. It was fun. I think it's still living in some shape and form. So
is Erlang hard to program? I mean, I've never even.
So the problem with Erlang is it's actually a very simple language. It's very concise, but the syntax is compared to say C or I'm going to use the J word, JavaScript.
We'll be talking more about that.
Oh yeah, I'm looking forward to it. Yeah. I love JavaScript. So Erlang is different. It has a very different syntax, and the problem with this is not an Erlang thing, but the problem with most people is that they actually they don't really look
What's
at
the problem with people?
I don't know. I don't know, Chris. The problem is people get stuck with simple concepts like syntax. Come on, spend like 2 days and syntax becomes a secondary factor, right?
I suppose, yeah. I mean,
when
any language has its
of course, and especially when you're dealing with things like so Erlang has this feature. A little quick plug for Erlang. Erlang has this feature where you can match patterns on the messages that you're receiving very easily, and the bit syntaxes and doing protocol level stuff in Erlang is beautiful, right? Because you just define grammars. They're actually part of the function body. They just call them function bodies, and then you can match on the incoming messages and so on. You don't have to do the horrible regex structures and stuff.
Right.
So it's I mean, for me, it's still a very interesting language, and I still prototype, quick and dirty things using our old framework sometimes. But I guess that was a long-winded way of saying it's not that difficult. Okay. It's just that you need to look past the syntax. Just don't get stuck on the syntax.
Okay, cool. So you're still defending, you said, on the PhD side?
Yeah, I defended.
Oh, you defended. Okay.
I got the list of corrections. I just need to find the time to,
Yes. Well, that could last another 10 years. We'll see. Yeah.
Yeah, I think
Someday.
I need to do that in the next 6 months or so. But we'll see.
Yeah.
I mean, I'm not going to let it go after this point.
Yeah.
I've lost enough hair over it.
Yeah, right. Yeah. So you've taken that and you've parlayed it now. You said you've done a couple other startups as well.
Actually, no, this is my first startup. After the Erlang stuff, I joined a hardware company.
Like an established one.
It was an establishment. Okay. It is still an establishment, actually. It's still there. And this was more of a kind of a much bigger scale and actual hardware as opposed to software.
Oh, okay.
Because I decided that while I enjoyed Erlang and distributed systems and stuff, I kind of enjoyed doing PCBs and electronics and embedded Linux, board bring up drivers, getting lost in datasheets and cursing it.
Well, and having both of those domain expertise is super important too. Being able to write the drivers, you need to know the hardware, right?
Yeah,
and that's super important.
To me, it's always about problem solving, right? I'm more interested in the system level problem that needs to be solved.
Right.
I mean, if that requires me to dive into the kernel, I'm not claiming I'm like an expert kernel hacker or whatever, but I like getting lost and learning something new out of it as well.
Yeah, you will definitely. If you plumb those depths, you will find a monster or two, right?
Oh, absolutely. And of course, dealing with big semi and vendor SDKs and vendor drivers. Here, have this like kernel 2.6 driver that kind of works.
Right.
But you're on.
You can just troubleshoot the rest of it.
Exactly.
Tell us all about all the errata. We'll put it back into the. You'll solve someone else's problem too. And doesn't that feel good?
It feels amazing. So yeah, I did a lot of prototyping, kind of everything from board level bring up to even towards the end of my tenure there, doing factory testing.
Oh, nice. Yeah.
It was nice because I got to see, it's not every day that you get to interface with big, factories and stuff in, Far East and all that stuff.
Right,
and,
right. It's like an eye-opener, right, for a lot of how things are really done, stuff
Absolutely.
Like that. I think we talked to Jeff Kaiser about that a bunch. I mean, not a bunch of people, but yeah, like the boots on the ground.
Yep.
Oh, that's what they're doing. Oh my God.
One thing I'm not missing out is, I was based in London. I traveled a fair amount, but I don't miss my 3 a.m. San Jose, London, Suzhou, China, meetups.
Wait, so when you fly, do you fly that way? Do you fly through like Dubai or something to get to China?
You could, if you really tried to. Yeah. Or you could just... when I go to Shenzhen, I just go to Hong Kong and then just cross
you can go here to Hong Kong. I didn't know. Okay.
London to Hong Kong is fairly established.
But you're going east either way.
Yeah,
right?
exactly.
Okay. Interesting.
But yeah, that was an eye-opener. That was an education. But after that, I realized I wanted to do a bit more of a concrete, get hands dirty, work with smaller teams.
Right, smaller teams, you work on more of the system, right?
Also, I was getting a little tired of traveling and living out of hotel rooms. It's not as glamorous as people think it is.
It isn't. It's nice at first.
But then... But
also Suzhou or wherever you end up going, and it can be the expat thing, kind of, not expat, but like the being in a rather foreign environment gets... It wears on you.
I was very lucky. I had a very nice support system. All the people I worked with were amazing. Amazingly, the hospitality they provided was amazing, and I enjoyed it. I learned a lot of things, but at the same time, I wanted to be, I didn't want to travel that much, and I wanted to just be in London for a while.
Right. Well, and having that knowledge is super important too. Knowing how to navigate the markets and knowing manufacturing stuff. Well,
the way I look at it is, it's everything is a learning experience, right? And if you can make it fun, you can keep going at it.
Right.
Because think about the startup environment. The reason I joined the startup environment is because it was actually quite an interesting project, and we'll get to it later. But B, there's a lot of things to be learned, and it's an opportunity to improve yourself, and at the same time do something that potentially can be big and nice and
and I think it's much like travel that eventually you might, if you went from startup to startup always with like a couple people, you always run into the same kind of frustrations.
The ultimate goal is to become a farmer and start producing cheese anyway, right?
Is that Your goal?
I mean, if you talk to anyone...
We were talking about cheese before, and I'm thinking about cheese.
The cheese mountain. Anyway, the cheese mountain. So, jokes aside, like, if you talk to anyone in the UK tech circles, like, becoming a farmer and, like, start producing cheese and beer is the ultimate goal.
Really?
I'm not talking about the next year, but, like, the ultimate
you just mean, like, simplicity and, like, kind of...
Yeah. Because, like, you can only deal with so many kernel, like, oddities until, like, you just want to do something with your hands, right?
Yeah. Well,
I mean, I took up
that's
carpentry.
when you start machining. Come on, man.
Yeah, I actually had a carpentry course I attended last year.
Nice.
But I had to cut it short because I had to go to California.
Right.
I mean, damn those sunny weather having days. And
you gotta hate being in Palo Alto on a nice day.
It's the worst.
Yeah. So how is it? I mean, we talk about, me and Dave talk about startups. You know, we've had other guests on who are startups, but you know, I guess. Well, I mean, we've had some startups, but maybe more kind of a big mix. This is a legit hardware startup.
Yeah, so we're doing a lot of hardware.
Yeah, which is good. I think there's interesting problems with that. Money, obviously, is always going to be a problem.
Yep.
But and one I always point out to people, I'm like, you know, like software companies, they raise a bunch of money, and their costs are like nice chairs, good computers, and people.
Snacks.
Snacks. Oh, of course, right. But then a hardware startup has to be like, oh, and also $100,000 in molds, or something, you know, or you know, a $10,000 prototype board that I got overnight, right? It's just like, oh, shit, you know.
Exactly. Yeah, regulatory approvals.
Well, we'll talk about that too. Yeah. So, what's it like for you? I mean, what's the experience?
So, my role in this company at Den Automation, I'm the chief hacker / CTO. So
chief hacker. Yeah. Isn't it on the business cards?
It is on business cards, but the funny story is, especially when you're dealing with manufacturing folks, they don't get it.
No,
because it's kind of a more mature industry.
Right.
They don't think it's funny. So I actually have two business cards. One of them just says chief technology officer, and one of them is just chief hacker.
Well, because they're also looking for people that are you're a decision maker as well, and that's what they're really looking for.
But then here's the thing: in a 6-7 person startup, right? Your title doesn't really mean anything.
Totally agree, but. Yeah, no.
But at the same time,
I've struggled with that too. Where it's like, okay, there's 3 people in a company. Why are you the chief this, chief that? It's actually, some of it is actually from a corporation standpoint. I know.
Yeah.
And then the rest, I think, is just because you need to be the decision guy.
True. And I do end up having to decide on all the technological elements of our of our products. But the experience has been great so far, and I'm really looking forward to the months ahead because. We're currently at a stage where we have done, quick and dirty prototypes with lots of wires coming out of it. Nice. We are prototyping our ID and, started receiving beautifully machined parts.
Oh yeah.
It's all happening, but it's hard work. It's not
long
standard hours. It's not a 9-to-5 job. Don't let anyone tell you otherwise.
No, I don't think anyone listening would really expect that.
Yeah, and but as I've mentioned, it's all like you learn a lot of different things, and one of the important things in a startup, and we've kind of been working with this kind of attitude since the beginning, is understanding and accepting your weaknesses and seeking for help or external, sort of sourcing different projects to subcontractors or agencies, design agencies, engineering companies. It's very important because if you try to, I'm not saying you can't do it, but if you try to solve problems that are best solved by, domain experts, even though it might cost you a bit more, it's going to make your life so much easier.
Right. Well, yeah, it's a kind of balance of because you talked about wanting to learn, right? So say that you had to go send out an email to your campaign backers or something like that, and you want to do that perfectly. Yeah, you might learn that stuff, but it's probably not. If you've got other stuff to do, you have to actually focus on the important things. It's
I completely agree. So we've been very lucky to have partnered up with some really great companies and organizations, and development is full steam ahead. Awesome. It's also nice to be able to iterate on ideas very quickly. That's one of the things I love about a startup. It also means it's a curse and a blessing, right? So if you think about a standard or like a well-established engineering company with lots and lots of divisions, offices spread around the world, you need a lot of documentation. You need a lot of spec work, and you need a lot of everything before anything can start. Right. By anything, I mean mostly development work.
Right. versus sitting next to someone and turning them and
sitting
going,
next to someone is a
let's
blessing.
try this.
Right? So in a hardware startup, distributed teams are very, very, very difficult to pull off.
Yeah.
Especially, like, I'm a strong believer that the firmware engineer should sit right next to the hardware engineer.
Yeah,
especially
in their lap almost.
Yeah, exactly.
Especially during like board bring up, important.
Yeah. So on more than one occasion, we were able to come up with an idea on Monday morning. Quickly research what's available, design a quick test board. Monday, Tuesday, send off for a PCB fab. Mm-hmm. At the same time, ID gets done. We have a quick resin printer in the office, which we love. And by Friday, we've kind of iterated on the concept with physical hardware in our hands already.
That's a great turnaround. Yeah.
I mean, it's think about it this way, right? Quick prototyping is amazing these days, especially when it comes to PCBs. 3D printers, I'm not a big believer in filament-based ones. I mean, they do work.
I mean, it's rough stuff. Depends how much finish you need on your stuff. So
I have one at home. I use it for printing lots of like L brackets, fixtures, quick things. It's great for that.
Like
I love
jigs
it.
and test holders and stuff like that.
But when you're trying to print kind of like a device prototype that you're developing, you kind of need a bit more resolution. And we actually have been very happy with our resin printer.
Yeah.
Not naming any names.
Uh-huh. But it's on your Twitter account, I think. So
we'll
let people go for it.
Exactly. Okay, that's fine. But we found that like if you actually spend a tiny bit of time with some wet and dry and actually prime it.
Oh yeah,
it looks amazing. I'll show you some samples later.
Yeah.
And that kind of quick iteration cycles are what I am really, really happy about.
Yeah.
Sometimes we don't even need to do custom hardware. You can just order development kits. Because development kits are almost free these days. People are dying to give you their development kits. It's also very funny how should I tell?
Sure. Yeah.
Right. I don't know. Big Semi trying to enter the whole development market. But we're targeting pro makers or maker pro. It's so funny.
Yeah. You mean everybody having Arduino pinouts on their thing and chasing?
Not just that, but like the whole market.
Like the mindset.
Yeah, it's just
I don't know. It's weird.
Also, like whenever people announce their development kit as this is all you need for from your development kit, that's just like no. Depending on the application, you need very many development kits or very many kit. Like
I think what they're expecting is that you're going to stop at a certain point. Not you, but like the people that they're selling to, right, is going to stop and be like, can I buy more chips from you? Can I talk to your FAE so they can design in parts for every other socket on the board?
I have a great story about this. So a couple of weeks ago, I was in Shenzhen. I still don't know if I'm pronouncing it correctly. I think it's
I say Shenzhen.
Shenzhen?
Yeah.
Shenzhen?
I don't know if that's right either, so who cares?
We'll go with Shenzhen. So I was in Shenzhen, and I, again, not naming names, Big Semi, they're in pretty much every kind of wireless access point device.
Oh, yeah.
Just before I left, just for a laugh, I gave them a call and I said, I'm interested in this part. I'd like to talk to an FAE. I'd like to create an account or open an account. Yeah. And they said, the first sentence was, unless you can commit to 250,000 units per year, per part or per product category or whatever, I can't remember, we won't be able to provide assistance. I was like, okay, thank you very much. Have a nice day. So
that's what I expected.
This is the thing, right? In my previous life, I was able to get access to these things very easily with just one email. Being a startup, you don't really get the luxury of, emailing FAEs directly from your startup email account. But
they still say they want to talk to you, of course.
Oh, absolutely.
They want the marketing side of it.
They'll sell you Maker Pro development boards and stuff, but try buying their chips.
Well, you just jump from 1 to
250,
250,000, you're good.
Of course,
yeah. That's easy.
Yeah, you don't need to go 1 million. You can do 250.
Only 250,000.
That's easy.
But per quarter, right?
Luckily, they said per year.
Okay.
I mean, that's the saving grace of the whole thing.
I forget who I was talking to you about that. They said, yeah, we do 10,000. Then they called him back the next month. So when do you want your next 10,000?
So it's a completely different mindset, and like they're not really interested in small fish. They're in for the big hitters, and you can't blame them, because if you think about the competition and the way they operate,
price for that, right?
This is not me like actually. Bad mouthing them or anything. It's just the way the market works, right? But anyway, so arrive in Shenzhen. I go to one of the many beautiful markets find the first stall, through Google Translate, ask to buy 4 of these chips. And I'll actually give you a picture so you can link to it.
Yeah.
And like 15 minutes later, and I think I paid 15 kwai per chip or something silly like that.
15
RMB.
So wow. So that's like it's like $2.50.
Yeah, something like that.
Yeah.
I got 4 beautiful chips taped to a piece of cardboard with like packing tape and in like clear.
Just slowly untape these. Yeah.
Yeah. It was glorious. I mean, of course, I didn't do anything with those chips. But in fact, I think. Oh yeah, I did. I did desolder on one of the development boards.
You say you should frame them. You should frame those 4 if you still have them.
I gave one to Aaron actually.
From Umlaut.
From Umlaut.
Yeah.
We happened to be in Shenzhen at the same time. So
nice.
Anyway, funny story. So the moral of the point of the story is that it's not a level playing field, right?
Right.
The access to these kind of things for a Western engineer is very, very, very limited. So when you're designing with those kind of devices, it forces you to until you reach a very, very good volume, use modules, which is a cost adder. You don't have the flexibility you have.
Right.
On this subject, last month, Ivan, our firmware engineer, and I gave a talk at the Open Source Hardware User Group.
Oh, yeah.
And it was all about discussing how you can actually start developing with these classes of like the wireless SoC class devices. Because these devices are great. For $2.50, you get PCI Express, USB, like a Linux capable processor. You just stick a bit of RAM and some SPI flash and you're good to run all your JavaScript applications, right? So, Chris is smirking.
Yes. Well, yeah. Anyways, go on. Yeah, keep going, yeah.
Anyway.
But I agree that the access to just the feature set is amazing, right?
Yeah. So where people are trying to push 32-bit microcontrollers into all these, applications that arguably require a bit more horsepower, you can see yourself using these classes of devices. Of course, the problem is they're much higher power than their microcontroller counterparts.
Right.
When I say microcontroller counterparts, I'm talking about things that don't necessarily run a full operating system.
Yeah, full stack, memory management, and RF.
Very, very limited memory. And this actually, especially in the IoT, results in potentially weaker crypto, slightly more convoluted ways of dealing with things, and so on and so forth, right? So, anyway, I like wireless SoCs, YSOCs. They're great, but
there's trade-offs.
There are trade-offs.
It's
as
engineering.
Welcome to the world of engineering.
Yes, engineering still valid.
Of course.
Okay, so let's talk about Den. I mean, so you had told me a little bit about this, and I got to see a demo today. Actually, no. Before we talk, should we talk about Den first, or should we complain about IoT first?
I'm not a marketing person, so I'll give you a 2-minute overview of what we're doing.
Okay, that's a good idea. I think we definitely need to complain about IoT in general.
Oh, we can talk about that. How long do you have until your flight tomorrow? We're close to bagels and Indo, so it's all good.
True. We can just survive here for a while. Yeah.
Okay, so Den automation. We're reinventing the light switch and the plug sockets.
Reinventing.
Yeah.
You guys aren't though. I mean, you guys are just enhancing.
We're enhancing it. Okay, so that's the usual one-liner that we use. But what we're doing is we're working in the home automation or subsection of the IoT domain, and we're kind of taking a look at all the products that are out in the market and saying, hang on a second, shall we do a bit more kind of user experience research? Shall we actually figure out what people need?
Right.
And most importantly, shall we just not introduce goofy user interfaces? I'm talking about hardware interfaces to people. So,
right. And I will point out as well that you guys are basically listening to me. We were talking about this.
Great.
I forget what show it was, a couple shows ago, where I was just complaining about, I want a switch. I want a switch to be a switch. Yeah. And Dave talks about the same thing. And surprisingly, that's what you guys are doing. I mean,
we're big fans.
Oh, yeah, that's why I have. No, I mean, I think it's a natural thing, though. It's like we were talking about natural user interfaces. Especially because when you're trying to sell a higher-end product, not high-end, but higher-end product, you're going to be selling to people that are mature, have money.
Yep.
Probably not 20-year-olds. They're going to be 50-year-olds that are used to, that grew up with switches.
Well, the UK housing market at the moment is ridiculous. Young people simply do not have the money to buy houses.
Good point. Right. Yeah. Right. So that's about knowing what your user actually going to use.
But that's not the main point. The main point is we're designing devices that, when fitted into or retrofitted into an existing house, won't look alien.
Right.
They will look exactly like their non-smart counterparts. But we'll have a whole bunch of smarts inside.
Right.
And the kind of mobile and web app approach we're taking is we have our in-house design team. We're doing all these UX studies. Our entire office is covered in UX studies at the moment. And really, we want to design stuff that we want to use as engineers.
Right. And people may be scoffing, but I think that actually is more important. Obviously, I'm out more on the website now, too. I understand a little bit more about it. It's more important than people actually give it credit for.
Yeah.
And especially when you start talking about consumer-level stuff, because this is what it's ultimately going for.
I kind of... There was a bit of a snuff earlier with my statement when I said we, as engineers, want to use these things. That we want to... We don't want engineers to look at it and say, "Oh, I can do all these different things with it." That's not our primary selling point.
Right.
Our main selling point is that we're designing basic user interfaces with very advanced tech behind it and creating beautiful relationships between different devices.
Intuitive stuff, right?
Intuitive is the word we're looking for, I guess. So if you look at the ideal IoT environment, everything should blend in, right? The whole ubiquitous, computing, whatever. So, and the most important thing, of course, is that your plug sockets or socket outlets should be able to talk in a meaningful context with your, say, fire alarm, or your light switches should be able to detect that something's going on in your house and perhaps turn things on so that you don't stumble and hit your toes. And these
intelligent devices, because that's probably a better term for the whole thing anyways, right?
I guess the underlying point is that interoperability is very, very important, right? And in the IoT world, that's one thing that we are doing a terrible job as an industry.
Right. Yeah, because everything kind of goes for flash and like, oh, look at this whiz-bang one thing.
Yeah. And I blame marketing folks for this, because I think it's the case that engineers want things to talk to each other, and it's not really a technical challenge most of the time, right? Of course, there are different communication standards, different wireless standards, and all that stuff. But we also it's just a battle of hubs in houses these days. Yeah. So you have a Zigbee hub, you have a Wi-Fi hub, you have some weird 433 or 844, I can't remember the US frequency, ISM band frequency. Yeah. So yes, that is a problem, but at the same time, it's more of the larger problem that we need to solve is the companies should stop saying, okay, we'll just create another walled garden, or we'll just create another alliance with all these big names. And the problem is there's a beautiful XKCD about this, right? If you have 16 standards, and if you try to solve this whole problem by setting another standard, now we have 17 standards.
That's right.
So
and they're all, it's almost like a pissing contest too, where it's like, no, me, my standard, and then the hope is just they'll get big enough that then it does become the standard, which historically has worked. SPI was a Motorola thing, and then eventually it just became a thing,
But at the moment, it's a case of a lot of these sizable companies saying, come integrate with us. No one's having what can we do to integrate with others conversation.
Right. Actual internet.
There are only a couple of, as a small startup, right? Obviously, we're not the big names that establish these, alliances, these grandeur names that actually don't mean anything. There are only a handful of sensible partnership programs out there.
Right.
But at the end of the day, Apple will do their own thing, Google Nest will do their own thing, and so on.
Sure.
So the interoperability and the integration between different ecosystems is the biggest challenge in IoT. And it's tough, especially for a company of our size. Going forward, we're probably going to have to dedicate serious resources or even a dedicated team of people to handle all the integration scenarios.
Yeah, it's like a business development type thing where you have to go and talk to Google.
And it's a matter of, it's not a technical challenge, right? You could put enough manpower to write adapters and all that stuff, but at the same time, which alliance should you be, joining? Which faction should you be joining? It's like
pick your side.
It's painful, but it's the biggest challenge at the moment. I mean, there's I'm going to give a talk about this at NMI and at an NMI meeting in the next couple of months. This is
NMI?
National Microelectronics Institute. It's a joint event by British Computing Society, Open Source Hardware User Group, and the National Microelectronics Institute.
Ooh, cool.
And the theme of the talk is open source is great. I'm a true believer in open source, and I can't wait to open source some of the stuff that we are developing here once we actually get to the point that we're happy with them, and also we clear all legal stuff, etc. But at the same time, open source is potentially a poison as well. So open source is a great enabler for IoT greatness and mediocrity. Right? So Can
you explain that more?
So okay, here's the thing. There's a wrong kind of openness that these whole let's set up a new alliance kind of approach is creating. So what they're saying is, okay, we're going to be open. We're going to give you access to our protocols and specifications and stuff, which is great. But at the same time, you really should have used some other open source or open protocol or open approach to the problem rather than inventing your own, right? And this is not a very popular. I've had very many discussions about this. So some people actually think that this is a dumb argument, but I strongly believe that there's like a right kind of openness to approaching a problem and the wrong kind of openness.
Sure, yeah.
But this is a bit like the previous discussion we were having, right? For I'm going to name it up, for Qualcomm to join some other ecosystem, that doesn't make business sense for them, right?
Right.
They need to provide the whole thing as a solution to sell to their folks. And what is this driven by? Their marketing team. So while the engineers at heart, they might want to be open and have this amazing, idealistic view of IoT where everything is talking to each other, it's a marketing decision to brand and try and sell that as a solution.
Right. Yep.
So it's a big challenge. IoT is, for it to make sense, we're going to have to work a lot harder in the integration standpoint.
Interesting. So how did this all start? I mean, what is the story behind the company too? So obviously we're talking about some of the realities of pushing it forward, but where did it start?
So Yasser, our founder, had this brilliant idea when he was still a teenager. He was at school, and he put together this mock-up, this proof of concept rig. And with that, he was able to raise a substantial amount of initial seed funding to put together the team. I know Yasser through previous contacts, previous connections, and for me, I've given presentations about how IoT is great and how IoT is terrible, and I have a love and hate relationship with it, right? So
sure, yeah. I think we all do.
I want it to work. But we really don't need any wine bottles with touchscreens on them, right? So, or maybe we do.
Is that the new one? No. I like that.
That exists.
No, I know. I know what it is because that was a YC company, wasn't it?
I wouldn't be surprised.
I think it was.
Okay, so that was a direct attack. I feel bad about it. But let's look at another.
We can bleep it out, maybe.
I don't know.
I feel bad about the bleep with the touchscreen on it.
It's generic enough that, yeah.
No, I think you're right about that, though. Yeah.
The point is, there are some amazing applications of IoT, right? Especially if you look at the healthcare, bringing services to, remote communities, sensor networks. Yeah. These are great applications, but at the same time, is it a tumbler that let's put a chip in it?
Is it? I don't know.
Yeah, there's a beautiful blog on it.
That, let's put a chip
basically,
in it. Yeah.
It's something along the lines of that. And there's also a beautiful Twitter account called Internet of Bleeps.
Shit.
Yeah.
Yeah, you can say it.
Can we? Okay,
yeah.
Internet of Shit. It's great.
Right.
Whoever's running it.
Oh, yeah.
My hats.
That was the one that you did today. There was no.
Is that coming next?
Yeah, we can cover that next. Yeah, so that was in reference to 94% of developers, 94, 98.
Something like that,
said that they would be using JavaScript as their main programming language for IoT devices.
Let me finish the then story and we'll get to JavaScript. So Yasser had this brilliant idea. Yeah. He put together the initial team, and even our initial hiring process was all, let's hire a UI UX person to be in-house first.
Sure. Yeah.
Let them drive the whole application design as opposed to just engineers putting together this kind of tech demo looking thing.
Yeah, thinking about it holistically, so you're having other pieces.
Yeah. So, I absolutely love what some other engineers have done in this field, and I'm not dissing the technology one bit, but we decided to approach it from a different perspective. And now we have firmware in-house, industrial design in-house, mobile/cloud. We interface with a partner for our cloud services, but we do the modeling, etc., on their systems. We have our UI UX person in-house, and for a short amount of time, we actually have an RF designer, RF engineer, a buddy of mine who had recently finished his PhD, joined us to help us with some antenna issues, because as a digital engineer, I do not understand antenna design.
I don't either. I think that's its own.
Yeah,
antennas are. I won't say black magic, but they're definitely their own thing. And like we talked about, like when you're starting to do regulation type stuff too, that's super important to make sure you get it right the first time. Yeah,
and also we're designing in-wall devices, right? So it's a nightmare.
Yeah,
It's not a nightmare. It's perfectly doable, and we will do it. But it's not an easy certification.
It's a design challenge. Yeah.
It is a design challenge, and you can appreciate there's a lot of stuff in it. So if you have a lot of metal behind an antenna, guess what happens?
It's like a ground plane.
Exactly.
Yeah.
So that's why we have someone helping us on that. And this goes with the previous point I was making, right?
Yeah.
As a hardware startup especially, just like identify and accept your weaknesses and get help.
Yeah. Speaking of weaknesses, I have done a bad job as a podcaster here. What are you guys making? So we're now 40-ish minutes in.
Are we? Oh wow!
Yeah. So what is the actual device that started out as?
We're starting off with plug sockets for our US listeners and socket outlets for our UK listeners. Devices that you plug appliances into.
Right.
And light switches.
Okay.
But we also identified that just having a light switch and a plug socket is not going to be enough. So we're experimenting with a remote. We envisage most of the interaction going through mobile apps because everything does these days, and everyone has mobile phones. But for certain cases where, for instance, one use case will be extending, an on and off switch on a lamp for a less able person.
Oh, sure. Right. You put like a touch pad on a chair.
We're very against touchpads. We like tactile feedback and tactile buttons. That's why we reinvented the whole mechanism in which we can actuate things. But
so we should also mention too with the UK sockets or whatever you call them.
So one thing that's different between UK and US sockets is that in UK all of our socket outlets our plug sockets are switched.
Right.
So we have.
So you can individually turn off. So you have a lamp plugged into the wall, you could turn it off at the wall.
Yeah, so there's a rocker switch in there that you can turn on and off, which is great. US,
in the US, you basically have to have it at each, usually in the wall junction.
Yeah,
and so that can actually control multiple plugs in a row.
Yeah, and our light switches look a little bit different than their US counterparts as well.
That's right. Yeah, right.
So we're starting with the UK market. That's where we are, where we're based, and soon after, in the very near future, we'll be starting our explorations into other markets. The US being the first one as well.
Yeah.
But it's a challenge because it's a different paradigm.
Sure. Yeah.
So it's going to be mainly a marketing challenge, and after that, a massive engineering challenge because the way the US sockets are made, the back boxes and the modular plugs, etc. It's very different. So I'm really looking forward to it.
Yeah, that's going to be... Well, and I think, from a space constraint, so I'm kind of been traveling around sampling all these different... As in Germany, they have the two-prong circular
thing. And all the other plug types.
And everything just seems bigger here, too, right? So the US one is definitely like a junction box. The US is pretty tight, so that's going to be a hell of a challenge for you guys.
We have an entire box of US products that we brought along many trips.
Nice.
And it's definitely a challenge, but we do like challenges.
So, so that's going to be good. So then that's connected, so each one's individual. So the one thing I like about the UK stuff is that because you have the safety turn off at each switch, that means you can basically individually control each plug, which is great.
So in terms of smartness, we're adding power consumption monitoring per appliance or per socket outlet, and also plug identification as well. So one approach to identification is just labeling things, but people unplug things and plug them elsewhere. And what you labeled your hairdryer now becomes an iPhone charger. Right? So we're working on a bit more... we're working on a technology that's a bit more smarter than that. So And it's and to support all this, we're exploring other sensors that we can integrate with our ecosystem. And yeah, that's pretty much it.
That's good. So then does that, so you mentioned that it talks to apps and stuff like that. Is it just straight RF, or is it like each one's Wi-Fi connected?
Details TBD.
Gotcha. Okay. So some kind of communication mechanism, but not necessarily, we can't talk about where it's connecting right now.
Yeah, we're kind of in the middle of a kind of a marketing launch for our new website and stuff. So
Okay.
we'll be announcing this very soon on our website.
Okay, that's fine.
But one thing that's extremely crucial for us, and I think this deserves to be mentioned, is that we'll ensure that even if the internet's offline, you can turn on your light switches.
Right. Well, that's ultimately what it comes down to, right? So like all of these things, it's like, so we're talking about natural stuff. I don't want to have to find my remote. I don't have to find my smartphone.
Yeah.
I don't want to have to do anything different than the normal go up and push a button and it turns on. So
that's what we're aiming for. I mean, I really want to believe in IoT. I think, I mean, it's somewhat clear now that I want to believe.
Well, you're working in a company that's in space, so
and we're making
better.
it. We're making it better, and we truly believe that. And this is not my marketing side speaking. This is like pure engineering joy. When we receive prototypes and they kind of reflect the ideas that we had. I mean, you do hardware, you know this feeling, right?
Yeah.
You know, when you receive prototypes and everything fits together and
shit,
it works. Exactly. And you can appreciate, like in a like a wall socket, there are a lot of components.
Of course.
So
we should mention that too. So that's another interesting thing, is that a lot of people go external from this because basically you guys are recreating a wall socket.
These are in-wall devices.
Right. So you're not using existing hardware. Like I think a lot of people would say, oh, well, I'll put a relay in line with the power or something like that. You guys are rebuilding the actual thing.
If you go to Shenzhen, you can just buy a plug-in adapter with Wi-Fi and a relay built in for not a lot of money. And a lot of products that are, effectively plug-in devices are derivations of that, design. I mean, we could have gone for the easy option and just rebadged or re-ID'd the entire thing.
And then just do the software layer. Yeah.
But if you think about it, it has its uses. I have used them in the past. In fact, I still have one turning things on and off at my parents' place. But I mean, it does look goofy. If you were to retrofit your entire house with all these things that are just sticking out of the wall, they get knocked off. And really, again, the software becomes a burden because, again, the nature of rebadging something, you just take their software and reskin it, right?
Right.
And it's a real problem.
Right, so if you're thinking of it from the user level, that's not quite great.
We're not going for the easiest option. We're definitely going for the hardest option, but we believe that it is necessary. We're, of course, standing on the shoulders of giants, right? We're not reinventing the wheel. We're using open source technologies. Some of the designs, when we actually publish more information, you'll be able to guess what technologies we use and kind of stuff. And
if we buy one, we just tear it apart too.
That also works. I'll put a little Easter egg in there for you.
Cool.
Little shout out.
Okay. Cool. Yeah, that's good. Can you make it so that when I open it up and there's like a PCB in there, it says this PCB made with chip runner or something like that?
Well, here's the thing. As a hacker myself, I thoroughly want this to be very open, but it's very difficult for a mass market product to have, to be to please the hackers and be a viable consumer product at the same time. Right. So an example, right? I would like to open up the API to the devices on the device level and give everyone access to everything. But guess what? A couple of people will do it. A couple of people will enjoy using it, but most people will brick it. Potentially, right?
Right, and the 6-person team can't support that.
Exactly. And building the support network and the RMA process for in-wall, live devices. It's kind of difficult.
Right.
So
I bricked my device and then I destroyed my wall trying to get it out of there. So
can you think of a scenario where if we were to allow access to all the facilities of the device, a malicious competitor, let's make it more sinister, released a dodgy firmware update that bricked all our devices.
Yeah.
I mean, that would be the end. Am I being too paranoid? But you see the point,
That's
right?
That's pretty paranoid, but I think it's if it got big enough. I mean, there are stakes, I guess.
Yeah. So let's discount the whole, competition being sinister fact. Yeah. But it's a very real risk that if you allow people to tinker with things, they can get the devices to do things that are potentially dangerous as well.
Right. Well, especially because it's playing with power, right? Yeah. That's another thing. So you guys, that is a big accepting fact here, is that you are designing devices that can literally kill someone. That's why you have to go through approvals and all that other stuff. And that's stressful, I'm sure.
What we're developing right now is surely not going to be what we're producing when we get to volume stage. Mm-hmm. It's going to have to go through several external design reviews, and then ultimately go through all the regulatory approvals, and that's when we'll be happy.
Mm-hmm. And what is regulatory here in the UK? What's that like?
We have a governing body called British Standards, and there's a whole bunch of different standards that we'll have to get through. I'll send you a list if you're interested.
Sure, yeah.
So, again, to the point, while I want this whole system to be very hackable, and interoperability being one of the key selling points that we will use, we still need to maintain a certain level of control, and simply for the safety of the devices and safety of the people, more importantly, right?
Right. So I think that especially like a consumer level device like this, it's in the name, right? It's going to be mostly consumers.
Yeah.
And then even the people that decide to dig into it will probably be from the developer side.
The details are being ironed out and worked on at the moment, but we'll definitely have a way where people can integrate with our devices. Details of which I don't know, to be perfectly honest. But again, we're not just using interoperability as a buzzword. We'd like this to work.
Yeah.
And I truly wish that more people had this kind of mindset or this approach, because then the lives of smaller companies like us would be much easier.
Right.
Because how many ecosystems can you realistically partner up with, right? You need to, at launch especially, you're not going to have the resources to do everything. And, the devices you're developing, you need to kind of decide on, one standard to use. And if that aligns with most of the standards, that's great, but it doesn't most of the time. So anyway, interoperability is a major, major problem. And I think this is like the 6th or 7th time that I've touched on this podcast, but it is. It really is.
No, I agree. I think that's the problem, is that that's the reason that it's been such a big deal so far anyways, is that it's such a vertical process where you need the mechanical, you need it to be safe, you need it to be, RF connected, you need it to have the firmware, you need it to have the software, you need it to have the cloud level stuff. That is the problem.
Yep.
And now you guys are trying to do it with a small team. So.
Well, we like hard challenges.
Good, because you sure as hell signed up for one. Okay, so you said there's you'll send me the standards, that kind of stuff. Let's talk about that Internet of Shit tweet that we were. So right now, if someone wanted to write an app level stuff for your thing, how would that even go? Obviously it's not out there yet, but.
You mean if someone wants to integrate with our stuff?
Yeah,
it will be. Think about all the other kind of respectable ecosystems. It will be on an API level, right?
Okay.
So whether it happens on the local network level or cloud level, we ideally want it to happen on a local level, but then there are challenges associated with that. So we're working on that. But I'm not just going to give people a C++ SDK and let them write code. It's going to be a process where they can pick whatever language they want and they use. So the whole JavaScript thing, I'm perfectly okay with JavaScript, but I do get a kick out of people talking about embedded JavaScript running on microcontrollers and those things being deployed in commercial applications.
Right.
I don't think that is the right approach to developing products, because especially not because it's JavaScript. Any dynamic language, anything that runs in a VM, it's ultimately going to be more difficult to prove and test, and I'm sure I'm going to get a lot of hate for this, and people are going to point me at all the unit testing toolkits and frameworks and stuff. But I strongly think that
even from a responsiveness standpoint.
Well, right? the VM folks have it easy. We're getting faster and faster processors, right? But I don't know. I think firmware should be. And also, I'm not of this school, but there's a school of thought that it goes by the belief that like maybe we should let embedded engineers write embedded code, and it's kind of a, I don't really want to be sided with that, but that has been mentioned once or twice in hardware circles as well. But then again, most hardware people can be quite bitter about things, so.
Yes, I do. Well, I think the only argument I would say for you guys is that the only advantage you have in this situation is that you're at a power source, right? And most devices don't have that. If they're battery powered, then these kind of high level languages are just not the right answer because of the amount of battery they take.
True, but that's not what the belief that most people have with the whole JavaScript argument, which is crazy.
Well, that's fine, but batteries are not cheap, and I don't like lugging around my extra battery,
Yeah, I mean, use the tool that's best suited for the job, right?
Right.
And
yes.
to me,
that
at
has
least,
been stated on this program once before.
Yeah, to me, at least, JavaScript for battery-powered devices is not the right answer.
Yeah.
Don't get me wrong. I prototype with a lot of like Lua VMs and Python and stuff. I love that because it allows me to really quickly churn out prototypes and proof of concepts and stuff. But when I, for a product that I am designing and ultimately will be producing more than 5 of, I would like to do it a bit more properly.
Gotcha. So you guys are going to you'll have an API level thing, but so basically, I mean, it's going to be the same kind of thing that your app developers are working with? Is that the idea?
Maybe not necessarily the same thing. There will be a huge overlap between those things. But things like the firmware upgrades I mentioned, it might be, we probably won't allow people to put arbitrary firmware in our devices, which is a totally justified view, right? If you want to void the warranty and do your own thing, you're on your own. You probably can stick, whatever debug interface we end up using on our boards and just desolder the SPI flash and put your own stuff in there.
Sure, yeah.
And I'm perfectly happy with that. But again, then it's not in our control what people do with the devices, right?
Right. Again, because from a safety perspective, you have to kind of protect
there will be loads of disclaimers about it, warning signs, stickers, embossed casing, markings and all that stuff, because we have to. It's safety of our users is of paramount importance, right?
Yeah.
So, and it actually scares me because these are once again,
well, it sounds like your name's on the the corporation paperwork too. So that means at a certain point you're actually liable, right?
Yeah. So this is why we're definitely going through external design review and very rigid process of compliance testing and regulatory approvals and stuff. So in that vein, we've been recently starting to set up our product lifecycle management and associated with that our quality management. These are the sort of things that most startups really don't need or have to deal with.
Don't think about in general, right?
Yeah. So, but because of the kind of...
Oh, you mean from the documentation standpoint? Because when you get because regulation is such a super big piece of documentation.
Yeah. So you have to take these things very seriously.
Right. How's that going? Is it okay?
These things are generally very expensive bits of software.
Oh yeah. Well, and I think that ultimately it's
it's necessary evil. We've accepted that, and it's unfortunately when you're running full steam ahead with prototyping, and when you again have such a small team, documentation and business process and documentation, these kind of things do take a huge chunk of your day.
Right. But you've at least looked at the system and you said, it's either an annoyance and an issue now, or a huge deal later, right?
If we try to deal with this right before we're about to press the button to order some units, we're in trouble. A, that's not the right approach, and B, we're not going to be able to do that, because the whole point of traceability and the whole point of the quality management and the product lifecycle management is that you start at the beginning. Yeah. This goes to our kind of CAD libraries, ECAD, MCAD libraries, and all that stuff as well. So it's taking a lot of time, I'm not going to lie, but if you're dealing with critical, safety kind of constraints, I feel like we at least have the obligation to do so.
Well, that's good. I mean, it's really good that you're thinking about that stuff up front, because, I always wondered, because, there was the Wink stuff from Quirky, and, they were just churning stuff out. Yeah. And that was the piece that I always wondered about, because a lot of them were very power based and stuff like that. And I'm just, how do you even do that? You know, like there's just so much overhead there.
It is, and there is, and so this goes back to what we're kind of quickly discussing in the pub last night, right? So becoming a pro maker versus going into the realms of like big boy manufacturing kind of thing, right? So this is not something you generally need to do if you're producing like a battery powered, you know, wireless remote or something.
Right. A sensor connected to a Bluetooth module.
Ideally, you should, because ultimately it will make your life easy. But like, you don't have to. But when you're dealing with like live power and people interacting with it, it's kind of a different story. But then, you know, there has been a lot of press and even books written about this whole pro maker thing, right? How do you go about prototyping to production? And you're involved in this as well. But the whole,
I feel like there's always that step in the between though, where it's like, well, you do this and this and this, and you need to raise this money, and you need to do all this other stuff, and then the unstated step is hire someone.
Yeah,
you know,
have
someone redesign your product.
Not just that, but if you think about the manufacturing side of things, right? Sourcing components.
I'm very familiar with this. Yes.
Yes, I was just using your tools today, but that takes an incredible amount of time just on your part.
Yeah.
In a previous life, I had the luxury of, you know, pinging someone saying critical parameters these. Can you give me a part? And a couple of days later, I had the CAD libraries ready and everything.
Right.
So,
exactly.
But I don't have that luxury now. So
right. The step one. Become a big, huge business.
Yeah. So no one really focuses on the. There's a lot of again, you know, books, articles, blog posts, Twitter streams, you know, about how you can launch your product on Kickstarter, how you can, you know, put together whatever. But data packs, standardized bombs. You know, what does actually a manufacturing team look like?
Right.
What sort of resources you need? What sort of steps you need to go through? What sort of product development, what are the standardized or accepted like product development categories in manufacturing, and you know, what are the etiquettes of dealing with, you know, CEMs and, you know, SEMs and all that kind of stuff. It's folklore. You don't get taught this at school. It's a huge learning process, and well, I'm hoping that people who've written the initial series of books will focus on that as their next project.
Maybe, yeah. I mean, there is some good stuff out. I mean, like the Bolt folks and, like, you know, the people that are, honestly, it's very China focused, I think.
Yeah.
And that's good and bad. I think that the interesting thing is when people are like, oh, I don't or can't do that. You know, and it's like, oh, well, that might not apply anymore then, but there is some general stuff.
No, true. And this is by no means, again, you know, dissing the great work that people have put together in this field. But the whole China discussion is another interesting point, right? Some people have the belief that, like volume China, volume equals China. That's not necessarily true. You know, through our explorations, we've actually identified great manufacturing partners in Europe, in Western Europe, and you know, China means that you have, like, if you don't have a dedicated Chinese-speaking person on the ground, this is very important. You're not going to be able to pull things off if you don't have like prior manufacturing experience. Even if you have prior manufacturing experience, but like, arguably, if you don't have a man on the ground, things are going to be a mess. So,
well, if it means if you don't have a person on the ground, that you will probably be that person as a hardware.
Yeah, exactly. But then if you're also, you know, if you have other duties that you have to attend to, things are going to take a beating. You're going to take a beating ultimately.
Right.
And like time zone differences and, you know, 12, 13-hour flights actually do matter when things are, you know, when shit hits the fan, for lack of a better word.
Yeah. And I think the main point being that China isn't always the answer. Sometimes it is.
Yeah, absolutely.
And if you're with a partner that already works there, that's great, but it's just not always the answer.
And also things work differently in China. There's a different handshake in China. And you need to be aware of these things. I mean, part of my explorations into visiting China factories and talking to people that do things over there, some very exciting things in fact, is trying to understand, you know, the culture difference and, you know, how things are run there. It's very different to, you know, a standard like Western CEM receiving a data pack, whatever.
Right.
And unfortunately, there's a real risk of, you know, your IP being, you know, kind of leaked or whatever, or literally taken to another factory and being produced side by side as well.
Or in the same factory at night, right?
That might happen too. So, like if I may, to any young budding hardware folks, volume doesn't equal, or manufacturing doesn't equal to China most of the time. You are probably going to have a better luck with a local enough manufacturing partner that is willing to take on a small startup and hold your hand through the process, because it's never just a case of here's my board files.
Yeah, right.
Think about it, right? If you're prototyping an idea, what you go to Osh Park. I'll very happily endorse Osh Park. They're amazing. Sure. Yeah. And you'll order some boards, 6 boards, multiples of 3. Yes. And you'll order some parts from DigiKey, Farnell, whatever. You'll solder them together, or you might even choose to use one of the quick prototyping services and have assembled boards delivered to you. Yeah. But then when you're working with a CEM, you never just send them a Gerber and just a half-arsed list of components, right?
Right. Whatever you have for 10K. Yeah, right.
Yeah, so that doesn't work like that. But unfortunately, again, you need to educate yourself before you reach that point, or...
Well, and the education is different depending on which CM you go to.
Oh, definitely. Yeah. Everyone has a different way of dealing with things. This is another reason why we wanted to formalize our PLM process, right? Because if we can have a repeatable data pack generation environment, that's someone should trademark that.
You just did.
I don't want to. Anyway, the point...
You mean like a standardized output, though?
Exactly. If you have a standardized output, and if we can manage our engineering correction notices in one place, and everything is just in one place, it will make our life easier.
Yeah, you're front-loading all of the shitty stuff that you have to deal with eventually, right?
So what I'm trying to say is you might actually have better luck succeeding in whatever you're trying to do with regards to manufacturing with a local partner, because especially if you're producing, a lot of something, even logistics becomes an issue, right? What are you going to do with all the things? Fulfillment, logistics, and if you look at Wired UK had an amazing series of articles this month on China and the new generation of Chinese companies like Xiaomi, like DJI. And
DJI is Chinese? I didn't know that. The drone company?
Yeah, I think their head office is there. But they have offices everywhere around the world. Yeah. One quote that stuck with me was when they interviewed Xiaomi, their model is no inventory. Just produce everything, ship everything as quickly as possible, and maintain minimum inventory, right?
And super lean.
Super lean. And this is what, they sold 100,000 phones in 4 seconds in India or something like that. Yeah, it's crazy.
I think mine is actually. Is that it? No, mine's a Huawei, I think.
Right.
Yeah.
So anyway, the point is, you'll have much better luck, especially if this is the first time you're doing this thing, with a local partner than just dumping your files in China.
Mm-hmm. Okay.
Do I come off as really bitter? I don't know.
I don't think so. I think I mean I don't think you're saying that it's a bad experience. It's just that you need to measure. No matter what you do, you need to have your eyes open, right? I mean and I think that people that aren't going to have their eyes open are going to screwed from the beginning, but it's just you need to be thoughtful about this stuff.
Yeah.
And you guys are front loading a lot of the because you recognize the regulatory load. That's really smart, I think. Does the regulatory stuff, does that impact the China decision at all or no?
Not really, because ultimately your quality management systems should flag up items that will cause problems in your regulatory.
Right, okay.
They should, right?
Yeah.
If material thicknesses are not what they should be, or if the material qualities are not what they should be.
Are you already speccing a QC plan for all your hardware?
We're starting it right now, but this is one of those things that we might have to bring someone in as well.
QC expert or something?
Yeah, because that's another discipline. We don't have a QC person on board yet. We're currently... A quick plug, and I'm terribly sorry about this. We're currently raising the next round of funds that we'll use to get to the pre-production stages right now.
Right.
So that part of that funding is going to go into setting up our manufacturing efforts.
Right. I mean, even just initial material cost stuff. I mean, you gotta buy the stuff, right? I mean,
for us, we're not going to be able to get away with just producing 3,000 of one unit.
Right.
We have to have we have to go big. Otherwise, you can again appreciate the complexity of such a device with all these functions, and it just doesn't make sense for us to be producing only a handful, hundreds of those things.
Right. And you mentioned that it has like current monitoring inside too, and it's like, removing that doesn't really give you much either, right? There's so much of the mechanical pieces.
Yeah,
and
it's mostly the mechanics.
Yeah. So like that's what's really interesting about it.
One thing that generally shocks people who are new to manufacturing is it's not the electronics cost. Boards are cheap, right? Components are cheap. Tooling costs for casings,
right? Assembly
costs, testing costs. Testing is an interesting topic as well. What you do on your bench, with your, Adafruit ISP programmer does not necessarily,
Right. And that's just at a board level too. You're talking about assembly testing. And I mean probably even power testing, right?
Yeah.
So and you said that plugs here are fused, so that is a godsend, I suppose.
Well, that is one saving grace. But then we need to ensure that an overload condition is not going to damage our power supply, for instance. And these things are built into the wall, so we need to ensure everything is.
Yeah, what is your lifetime you're going to spec on these things?
TBD, but it should align well with
I expect 10-year-ish.
Yeah, 10-year-ish figure is what we're aiming for.
That's a really interesting. Do you have to do failure detection on the firmware side too?
There's a quite a serious amount of diagnostics, real-time diagnostics happening in the firmware.
Yeah,
monitoring things. And
I forget I saw some tweet the other day that said, I bought a smart light bulb that was spec for 20 years, a smart LED light bulb that was spec for 20 years, but the RF failed after 2, which I expected. So now I just have I guess my 18 years it's not a smart light bulb anymore, And that's kind of another thing where it's like, that's some long timelines that a lot of people expect, right? When you buy a house, you expect
Oopsie.
Buy a house, you expect to knock your beer over. You buy a house, you expect all the fixtures are going to work, that they're easy.
Yeah, we're not designing things that you put in your wall, potentially spend a lot of money just installing them, calling an electrician or something, and then they're dud devices after 2 years.
Oh, because here you actually have to have an electrician install stuff?
Yeah.
I know Dave's talked about that with 220 as well, so
it's
in the US I shock myself all the time, I'm fine.
But your kettles take too long to boil water.
Oh yeah. There's the big trade-off. That's what we really need to be talking about.
As a kind of British person, kettles are a big problem.
It is faster here, I will say.
Oh yeah,
it's shockingly faster.
Yeah, scary as well.
Yeah.
So it's QC and reliability, and these are things that we take very seriously. And ultimately, we appreciate how difficult some of the things we're doing are, and it's only when you start thinking about the lifetime of a device that certain things become an issue. Like you were talking about radios, for instance, and all these things. It just adds up, right? The list of things you need to ensure that they're fine it's quite long. So fun times at Ben Automation offices.
Oh man, you're gonna have a hell of a time. Are you guys currently? So you did that was already crowdfunded once, is that right?
So our initial round, a seed round, was on Seedrs, our platform for raising funds.
So people can't buy these right now. So if we have UK listeners right now, they couldn't go buy one, or
our second round of crowdfunding campaign is now active. We're actually actively raising funds now. So
okay.
It's a convertible round, so this is by no means a financial advice. Just go read the page. It's the description is there. I'm an engineer. I'm a lowly electronics engineer. I'm not going to go into finances in this podcast.
Right. Yeah, that's fine. Okay, but if people want to get in on this, they can.
Yeah. But ultimately, just to recap our kind of driving kind of mantra, it's just making things kind of beautiful, functional, and ultimately simple, that can be integrated into other ecosystems and all that stuff.
Okay, so now the real question, because we're hour 15 in. How soon am I going to find out how the little thing switches on or off? So the demo I saw, again, now that we're this far in, we should mention more about how the device works. It's a real cliffhanger here at the end part of this week. So I could switch the light on and off, or the socket on and off, and then I can grab some other device,
mobile app, whatever, or remote,
hit a button, and it physically switches.
Yep.
And you're going to be able to talk about that soonish?
Very soon.
Okay.
We have
I should set like a reminder on my phone, maybe like a month from now. I can bug you. Yeah.
We'll hack some of the 220 units to work on 110 and send some over your way.
Ooh, that'd be fun. Yeah.
With a huge sheet of disclaimers.
Yeah.
And a huge RCD stuck to it as well. So we've evaluated quite a few different technologies for the actuator mechanism. Last week we signed off on the concept that we believe will make into production. At the moment we're still in prototyping stages.
Yeah. Well, it's super snappy too. I mean, like that.
Yeah.
Everything looked really. So, like I said, we've talked about it before. Everything looked like I expected it to look.
After we're done recording this, we'll give you a quick response time demo as well.
Ah, good. Because that's another big piece too, right?
Yeah. So we've like along the way, all the tools that we discussed, rapid prototyping, quick iterations, prototypes all along the way. We've been lucky enough to source all the beautiful development boards that we have these days, put together test clusters to test connectivity, response times, range, and all these things. And we do a lot of test-driven hardware development in which we just breadboard everything, solder up like quick prototypes, and it's great because verification in hardware all along the way is. I'm more a believer of that kind of a concept than just writing a 60-page document that mandates how things should work. But then, when you get to implementation, you might find that actually you can't really do that. So,
nice.
We're lucky. I mean, as a hardware engineer, I feel blessed almost to have access to all these quick prototyping services. The machines.
This is the time, man.
It is the time.
Yeah.
So I'm very happy.
Yeah.
Well. Except I'm not. So.
Well, you still have to make us things. So the thing that's always stressed with that.
Yeah.
Is there any last raging we should have about IoT? This is a term because I was thinking we were going to have some like raging. We complained about IoT after the whole show.
I think we've done well.
This has been much more like a great discussion about manufacturing and reality.
Yeah, we've contained ourselves on that IoT rage concept. I mean, at the last open source hardware camp in beautiful Hebden Bridge in West Yorkshire last year, I gave a talk about, I think the title was IoT, the Great IoT Hardware Kerfuffle. People talking about, making things connect to each other and platforms, and again, it's great to be able to have access to like a flurry of development boards and stuff, but there's certain things that are better suited to limited range of applications. So a battery powered Raspberry Pi, probably not a great idea. It can be done.
How big's the battery?
Yeah, exactly. It depends on how big the battery is. Then you're fine. I take that argument back. So it was a talk that I ranted quite heavily in the first couple of minutes on the unnecessary IoT applications.
Yeah.
I believe the Bluetooth toilet was mentioned.
Okay. Yeah.
My favorite was the Bluetooth toothbrush that enabled a personal brushing journey.
Aha. Yeah, at least 2 minutes, right? You could do that with a kitchen timer.
Yes. Anyway, so. In that presentation, I did actually discuss like the different kinds of, or different classes of hardware or processors that we have, mainly focusing on the processors, and what are the weaknesses, strengths, and I think again we've done a very good. I think we got it out of our system last night in the pub when the discussion on IoT
happens,
kind of all great discussions happens in pubs and great product decisions as well.
Of course, yeah.
We've contained ourselves well for this podcast, I feel.
Okay. Yeah. Well, if we feel the urge to rant more,
let's take it to Twitter. Let's take listener feedback on how great or how terrible I am. Am I doing this right?
I think so. Yeah, that's good. That's very social of you. Yeah. Now, the Den automation. If you complain about IoT, a light turns on somewhere.
Yeah, every time you complain about IoT, Deity makes a kitten cry.
Right. Awesome. Well, hey, thanks for being on the show.
Thank you very much for having me. Yeah.
Recommend people check out Den Automation. I think it's going to be. I think this is, like I said, I think this is the best. May not be the final answer, but it's definitely a step in the right direction.
Thank you. That means a lot.
Cool. Thanks for being on the show.
Awesome. Thanks for having me.